We're now going to take a look at an example of linear regression. Here we're given data comparing the drop height and bounce height of a ball. Notice the first column is the drop height, the second column is the bounce height. So the first step is to analyze the data by making a scatter plot, which means we're going to plot these points on the coordinate plane, where the first column will be the x-coordinates, and the second column will be the y-coordinates. Before we do this, we want to scale our axes to make sure it accommodates the given x and y coordinates. Notice the x-coordinates range from 6 to 36. So let's go ahead and label this from 0 to 40, and then break this in half. That would be 20. And we'll go ahead and cut this in half as well. That would be 10, and this would be 30. And notice how it is labeled in inches. And then for the bounce height, notice the range is from 3 to 18.1. So let's go ahead and mark 20 at the top. We'll cut this in half. Call this 10, 5, and this would be 15, again in inches. And now I'll go ahead and just plot these points. So the first point would have coordinates 6, 3. So that's going to be somewhere in here. Next point is 12, 6.4. Maybe somewhere in here. Next point would be 18, 8.9. Maybe approximately here. Next we have 24, 12.8. So that'd be somewhere in here. Then we have 30, 14.3. Last point would have the coordinates 36 and 18.1. Then once we have the scatter plot, we can see the data is behaving in a linear fashion, which means a linear equation would be a good model for this data. Notice how they're asking us to sketch a best fit line for the data. So we'll do this two ways. We'll first just do it by hand, and then we'll use the calculator as well. So if we were going to sketch a line to represent this data, we'd want a line that passes through the middle of these points, or maybe something like this. And now we'll go ahead and use the graphing calculator to determine the equation of this best fit line. So our directions are use a graphing calculator and perform linear regression, round to the tenths, and then use this equation to predict the bounce height if the ball is dropped from 52 inches. So the first step is to enter the data into the calculator. So we're going to press the stat key and then enter. And notice how I have some old data in here. So I'm going to go to the top of the column, press clear and then enter, and it clears the entire column. So we'll do the same for L1, clear and then enter. And now we'll enter the data. Now we'll enter the second column of the y values. It is important that we double check these values because if one of them is off, the equation will be off as well. And now instead of just determining the equation, we're also going to create the scatter plot on the calculator so that we can graph the linear equation right on top of the scatter plot. So the first step will be to adjust the window just like we labeled the axes. So we'll press window. Let's change the x minimum to -5 to make sure we see the origin. Then again, the x max we'll use 40. We'll scale this by 5s. And then same thing for a y min, we'll start at -5, and the y max we can leave at 20, and we'll scale this by 5s as well. So now if we press second y equals, we're going to go ahead and turn the first stat plot on. So we'll press enter, highlight on and press enter. And with these settings here, scatter plot, L1, L2 in little boxes. So from here, if we press graph, we can see our scatter plot. And now I want to perform linear regression and then graph that line right on top of our scatter plot. So we're going to press the stat key, right arrow once to calculation, and then number 4 is for linear regression. Notice that A is going to be the slope and B will be the y-intercept. So we'll arrow down to number 4 and then press enter, and then enter one more time. And here's the equation for the line of best fit. One thing we have to be careful about, though, is they are asking us to round to the tenths. So we're going to round the slope to 0.5, and we'll round the y-intercept to 0.3. So our equation is going to be y equals 0.5x plus 0.3, where x equals the drop height in inches, and y would be the bounce height in inches. Let's go ahead and enter this equation into y1. So we'll press y equals, and then 0.5x plus 0.3. Now if we press graph, we can see that line is an excellent fit for the given data. And now to answer the question, we want to know the bounce height if the drop height is 52 inches. If we want to do this by hand, we would replace x with 52 and then simplify, but I'll also show you how you can do this on the calculator. We could use the table feature, or we can go back to the home screen, press second mode, vars, right arrow, enter, enter to select y1, and then in parentheses, we'll type in 52. And this should remind us of function notation. And we can see here we're going to approximate the bounce height to be 26.3, and this would be inches. And that'll do it for this example.